You guys like having small groups all the time? I guess your other classes now.
Wait,
They're mixed.
can I have my paper back?
Yeah.
Not that much bigger.
But they give us different kids, is what I was gonna say. If you're mixing with. You get away from your nice small algebra group level. Would you guys probably prefer this, huh? Than mixing with some of the other kids? So go ahead and take out your assignment from Tuesday. Did Tuesday in class to work on it, yesterday to work on it. You guys would just have like the virtual copy if you were at home. Go over it. If you guys at home have questions about it, just look at 1 through 5. So I have a bunch of stuff written on. I think this is what we need to look at. So we start talking about slope. Today's notes. We're going to learn some new vocab for the same ideas. So a different word we use to talk about slope, specifically for situations where there's a constant increase. But any questions on 1 through 5 on these? We talked a little bit about on Tuesday for like number 4 and 5. Parallel means equal slopes. So you would have had to have gone in and calculated the slope for all 3 lines to figure out which ones were the same and which ones were different. I know it's hard to kind of see my pen on top of those grids. But any questions on anything like that? What do you? You're good? There were some questions that came up with number 2. Undefined is always a vertical line. So if you plot a point, just draw a vertical line through it. If your slope was 0, if you had to do one like this and it said through this point with a 0 slope, you could plot your point, and then horizontal lines always have 0 slopes. So it would kind of be like number 2, but instead of vertical line, it'd be horizontal. Any other questions? Rose?
Number 3, how did you mark the 2 plot points? Because that's not what I have.
Maybe I messed it up again. Because you called me on my other one too. So let's check. So 2, -3. So over 1, 2, down 1, 2, 3. So that is my point R. And then my slope, a vertical change of -4. So I go down 1, 2, 3, 4. And then a horizontal change of +3. Move to the right 3.
Oh.
But, and is that the variable that you were thinking about the other day when you were asking me? Remember when you asked me what the variable?
Oh, yeah.
But like, it's just a way to label the point.
I thought it was like the equation.
Yeah, no, I didn't realize that, and then I didn't know what you're talking about, but then Daniel was like, I think she's talking about this, and like, that would make sense, but it's just a way to label the points, you know what it is.
Because like I thought that R was like the second plot point, so you would need to go up 4 but back 3 to find the first.
So you would have,
plot point.
yeah, so you could have still got the same thing. So is your line the same?
Yeah.
Okay, so then if you have a different point, that you could have done it that way also. So you could have taken this and just like you said, if you go up 4 and then to the left 3, my point would be there, and you can see it's on the same line. Since left is a negative direction, you can go up and left, or you can go down and right. It's the same thing. So then what's next? Figure out if they're parallelograms. So you needed to make sure both pairs of opposite sides were parallel. So I ended up checking, just by chance, I checked the slopes of AB and DC first, and I didn't get the same thing. So since my slopes were different, they're not parallel lines, so it's not a parallelogram. Whereas number 7, I checked L and M, K and N. They gave me the same slope, and then I did NM and KL, and those gave me the same slope. So since opposite sides are parallel, it's a parallelogram. Any questions on 6 or 7? Abby?
Does it matter which variable you prefer?
No. 8 through 11. These are the ones where you have to set up your proportion. Again, using your knowledge of what the slope formula is. So I know I can calculate a slope by subtracting my y coordinates. So that's what I did here. I did 8 minus 4 because I have y and y. And then subtract your x coordinates. I just have x minus 2. So then I take a step to simplify so it's easier. 8 minus 4 is 4. So then once I have that big proportion written, because if this is how to represent a slope, it's also telling me that the slope is equal to -1/2. So I set it equal to that. And then I cross multiplied to turn it into an equation that I could solve. You didn't really have to get that far for number 11 because I needed an undefined slope. So that means you're always undefined if you have a 0 in the denominator. So I started just writing it out. It doesn't matter what's in the top. If your denominator is 0, it's always undefined. So then I just looked at this piece. What number can I plug in for x to get 0 as an answer? So if x is 3, then that means in the bottom here I would do 3 minus 3, which gets you to 0. So I kind of shortcutted that one. Any questions on any of those? You okay? If I switch it? Good? Am I sharing my screen here? Yeah. And then true or false, rate of change must be either a positive, negative, or positive or 0. That's false because you can have negative change. We looked at an example of like spending money in a bank account is an example of a negative rate of change. You also have undefined slopes. All horizontal lines have the same slope. That's true. Your slope is always 0. 2 lines may have the same slope. That's also true. That's how you create your parallel lines. Slope of a line that passes through quadrant 3. Are you guys familiar with the terminology of your quadrants? Okay, so I read that after I passed it out to you, and then I realized I never kind of went over that. But you have your 4 quadrants counterclockwise. So 1, 2, 3. So I drew an example here where my line is passing through quadrant 3, but it's a positive line. So it doesn't have to just be negative. So that's not a true statement. And then 2 points with the same x coordinate are always on the same vertical line. That's true. And I used my picture here to show it. So the x value here is the same. So if your x value is the same, then it's always going to fall on the same line no matter where you go. Anything with those 4 or 5 on the other 5? Good. These ones should have been more straightforward. Just find your slope. So you were given points on these lines, so it was even easier. So then just count your vertical change to your horizontal change. The only thing I could mention is to make sure you're simplifying. So like for -6/3, reduce this one, 3/1, reduce. You always want your slopes to be reduced. It just makes the math easier if you have to use it later on. But those should be easy, just counting. The only thing you want to be on the lookout for on problems like this is if your scaling was different. And like that's like what we were looking at this morning where you were counting by 3s with the number of baskets. So for example, if you notice that on your y coordinate or your y-axis, this was 10, 20, 30, 40, 50, then technically this wouldn't be a change of 5, it would be a change of 50. So it's easy to just like see the grid and just count the boxes, but just be on the lookout for a difference in scaling, which typically on like there's no context behind these problems, so you're not going to probably see that. But with some of the word problems that were on the end of the packet, it did happen like that. These 6, you just had to use your slope formula. So you're just subtracting your x coordinates, subtracting your y coordinates. The difference in y goes on the top, difference in x goes on the bottom. And then again, always try to just reduce. The only one that really reduced here, I guess number 28 did too, but 25 and 28. And then just be careful with your negatives, common mistakes there. 3 minus -2, remember that you're adding, so technically we get 5. So just be on the lookouts for this. That's like straightforward, this is the formula. Not too much thinking on like what to do, you're just following the process. Are you okay with that? Good. And then, is this the last page yet? No. So this is more the same thing. 0 on the bottom is undefined, 0 on the top is horizontal. If you get confused with which one is which, you can take these down and like type this into your calculator. If you type in 0 divided by 7, it's going to tell you that your answer is 0. Whereas if you type 11 divided by 0, it's going to tell you that you have an error. So you don't have to leave it here and then try and remember, well, I can't remember if the 0 on the top is undefined or if the 0 is on the bottom. Check it in your calculator because it will either tell you 0 or it will tell you that you have an error. And then your last ones. These are the ones where I was talking about you had to be careful with the scaling. So like for number 32, we're counting by 3s. So it may look like you have a vertical change of 3 when you count from your 2 points, but if each block represents 3 units, then that's technically a change of 9. And then when you're asked to explain what the slope means, it's how the y changes for one change in x. And this is going to be kind of the focus of what we're talking about today. Graphs like number 32 and 33, what we call that slope in a situation like this, how to explain it, and again, how the y changes. So for number 32, how many baskets or how many points per basket. For number 33, how many miles per second, how many feet per second for number 34. And then number 35 asks you to just kind of analyze and look at those two graphs. That last answer should be 4 weeks, I think I have. I can't read my writing, but maybe. Is that right? It might be 11 weeks. I'm just guessing because you see how it's chopped off. It's probably 11 weeks. I assumed it looked like a 4, but it could also be an 11. But any questions on anything on that page? All right, you can finish up looking at that. Make sure you do turn that in if you haven't. And then those of you at home, you can open up the new note sheet. I'm going to pass these out to you. We're talking about proportional relationships, which are specific situations where both variables in a problem change consistently. So they're going to be problems just like number 32 and 33, where it's a straight line. It starts at the origin. Are you guys familiar with the term origin? Like 0, 0. So you start at 0, 0, and you have a constant change all the way up through the graph. So when we have proportional relationships like that, our terminology of slope, rate of change, has a specific name of constant of proportionality, but it means the same thing. But a constant of proportionality just means that it is a specific problem like this, where we're starting at 0, 0. As the number of baskets change, I'm changing by a consistent amount in the y. But we're going to get into all that and what that actually all means. So if you look at your problem, I can find the mouse. So we have two problems. The first one says that when Andrew makes chocolate milk, he mixes 2 cups of milk with 3 tablespoons of chocolate syrup. This is a proportional relationship because if you look at the table, I'm going to have a consistent change in the x and a consistent change in the y. So what that means is if I take any row in the column and divide the y by the x, 3 divided by 2 is 1.5. 12 divided by 8 is 1.5. 3.5 divided by 1, 15 divided by 10, you're always going to get the same thing. So specifically in a table where every single row in the column lets you divide and get the same thing is a proportional relationship. That value that you get, that value that you get when you divide across is called your constant of proportionality. So in this table, and we're going to leave them as fractions because we like to see slopes as fractions. Constant of proportionality, it means the same thing graph-wise as the word slope, but it's just different vocab. So we use the letter K to represent it, but in a table, if I take the y column divided by the x column, that tells me the value that I can multiply anything by to get your resulting answer over here. So if I do this pattern here and I take 3 divided by 2, my constant of proportionality is 3 over 2. It's the same thing as your slope. If we want to talk about what that means, it's how much the y column changes for one change in the x. So this is telling us that you have 3 over 2 tablespoons of syrup per one change in the x. So per cup of milk. So it is exactly the same as your rate of change, exactly the same as the slope, but constant of proportionality specifically just means these situations where you're moving at a constant rate. And a little bit later on, we're going to see maybe when that doesn't happen and how we can't just divide right by left and get the same number. So this vocabulary is specifically just continuously dividing right to left, you get that same value. When you divide right to left, that's your constant of proportionality. It's another way of just saying the slope. So the slope of our line would be 3 over 2. So if we wanted to graph this, plot your points, over 2, up 3. So I'm counting by 2's here. So if I go over 2, up to 3, I'd be about here, 8 to 12. proportional graphs always start at 0, 0. Always straight lines. So we don't have to take the time to plot every single point. If we only plot a couple, we know it's always going to start down at 0, 0, and it's always going to be a straight line. So as best you can, then you would just want to connect it through the rest of the graph. The straighter and more accurate you make your line, you should see that the rest of the points fall on that same line. So if I come over to 10, I'm probably hitting about 15 on the graph. What's important about the graph is this, well, what's important in the graph, in the table, anywhere you see it, is that x value of 1. That's where you see your slope. In these specific proportional relationship problems, we're calling it a constant of proportionality. But it's always just talking about if x is 1, what's your y value? So if you look at your graph, when x is 1, that's where you find your coordinate 1, k. And again, k just stands for your slope, stands for your rate of change. In this problem, it tells you how many tablespoons of chocolate syrup for 1 cup of milk. So in this problem, that k value is 3/2. When we're talking about writing equations for situations like this, how can I get any number over here? So what do I multiply 1 by to get 3/2? What would you multiply 1 by to get 3/2?
1.5.
Right. 2 times 1.5 is 3. 8 times 1.5 is 12. So when we're talking about writing the equation, if we use the letter y to represent tablespoons, the letter x to represent cups of milk, our equation would say that we can get the tablespoons of chocolate syrup by taking that constant of proportionality or that slope or that rate of change, and all is the same thing. In this case, it's 3/2, multiplying it by the cups of milk. So it's always whatever's on the left, multiplied by your constant of proportionality, your rate of change, your slope, whatever you want to use, and it's going to give you this value over here. It's the same number that shows up at 1 in the table. It's the same number that shows up at a coordinate of x at 1. All means the same thing. So if all you're given is an equation, that number in there tells you what you're changing by. Does that make sense? So if we look over on the next one, it says a plane flew at a constant speed between Denver and Chicago. It took the plane 1.5 hours to fly 915 miles. So I have that filled in. So if I want to fill in the rest of my table, and again, keep in mind that this is the main row I'm interested in, because 1 tells me my slope of the line, tells me the rate of change, constant of proportionality. If I want to figure out what that is, divide out what you know in your table. So if we want to do 915 divided by 1/2, or 1.5, what does it give us? If we want to do it in our heads, we remember our rule for dividing fractions. So if I'm doing 915 divided by 3/2, it's the same thing as saying 915 times 2/3. So I can divide by 3 first. How many times does 3 go into 9? 3 times. So multiply, cancel, bring down the 1. 3 doesn't go into 1 any number of times, so I'm going to bring down the whole 15. How many times does 3 go into 15? So we get 305. So 915 divided by 3 is 305. I still have to multiply by 2, so it's 305 times 2.
610.
610. So do you have to do it that way? No. I'm doing that because there weren't too many calculators passed out. But we get 610. 915 miles divided by 1.5 hours tells us that in 1 hour, we can travel 610 miles. So again, the idea behind all of these problems is that there is a constant change. So it's not changing. So in 1 hour, I go 610 miles. In 2 hours, what are we going to go?
1,220.
We take that constant of proportionality, the letter k. That's the slope, that's the rate of change. Please do not get too confused that this is completely different than the stuff that we're doing. For some reason, there's just so much different language that all means the same thing. So k is 610, The rate of change is 610 miles per hour, so 2 times 610, like Casey says, is 1,220. So if it's 2.5 miles, 2.5 times 610. What did you say, 1,000? If you wanted to do that part in your head, we already know 2 times 610 is 1220, so then I just have to take half. So half of 610 is 305. So then we could have added 1220 plus 305. You get the same thing. Now we want to graph it. So again, we're counting, our scales aren't that great. I don't have to necessarily plot every single point. I know that in a proportional relationship like this, I'm always starting down at 0, 0, right? If no time passes, then I'm not moving at all. So I'm always down at 0, 0. My points have to form a nice straight line, so I can use that knowledge to help me kind of estimate where the points are gonna go. So if I have 1 hour, 610, so right in between 500 and 1,000 is 750. So I'm gonna come somewhere in between 500 and 750. Then I'm gonna jump to 2 to try to graph 1220. So I'm gonna come over to 2, up to 1220. And again, my points have to create a straight line. So I'm using these two to kind of guide me, to help me estimate, maybe about right here. And then connect them. And the straighter and more accurate you make your line, you should see that the other ones fall on. And then you want to be aware that that constant value number shows up on your graph at a value of 1 on x. So that point should be there. If we wanted to write the equation for this data, we don't have to use x and y. What letter do you want to use to represent distance? It can be anything. D. What letter do you want to use to represent hours or time? T. T. So then if we want to write the equation, what do I multiply everything on the left-hand side by to get everything on the right? My constant proportionality or my slope. So 610 times the number of hours is equal to your distance. You can always use x and y, or if it's a little bit easier for you, make your variables match the words that they are. But your slope, your constant of proportionality, your rate of change shows up in a graph when x is 1, shows up in your equation as that number that you're multiplying your independent variable by, shows up in your table, again at 1, or you can just divide any row in the table and you're going to get the same thing. Make sense? Again, it really is all the same idea of slope that we were working with before. Constant of proportionality specifically just means these situations where there's a constant change. Eventually, we're going to see situations where we don't have that. So this is kind of just summarizing everything that we just talked about. Direct variation, I'm not really using that because it's just more, it's new vocab meaning the same thing. So we don't need to be confused with all of these other terms. Direct variation is just this proportional type relationship. It's no different than the stuff that we've been working with. One variable is multiplied by a constant to get the other. We see that in an equation. It's always going to be written like this. I have some independent number multiplied by the same value, and it's going to get me an output. That k value is your slope. It's your rate of change, your new vocab for it, constant of proportionality, anything like that. I think on your homework it's worded as something different. I can't remember off the top of my head how it is, but it's similar to constant of proportionality, but it's all the same thing. You see it in a graph, proportional graphs, go through the origin, constant straight line, nothing crazy happening. Your slope or your rate of change shows up when x is 1. And then again, you see it in the table, either your value of 1 is written there, or you can find it by taking a y value divided by an x value. In that example, you can see you're always going to get the same thing. 6 divided by 3 is 2, 4 divided by 2 is 2, 2 divided by 1 is 2. So your slope for that problem or your rate of change would be 2. So for A, it says a certain shade of pink is created by adding 3 cups of red paint to 7 cups of white paint. So it's a proportional relationship. If I want to keep making the same shade of pink, I want to change both amounts of paint the same, right? If I add too much white, then it's going to be lighter. If I add too much red, then it's going to be darker. So we want to figure out our constant of proportionality. Keep things as fractions, because a slope, when it's written as a fraction, shows us how we can move, right? Top number is the vertical change, bottom number is the horizontal change. So what do I get as a fraction when I divide the right side of the table by the left side of the table?
7.
That's it. 3/7. So for 1 cup of white paint, I need 3/7 cups of red paint. Again, you want to keep it as a fraction so we can easily see how we can graph the points. Yes, we can just plot these, but if we know that this value is the same thing as our slope, we can also draw our graph, always starting at 0, 0. But if my constant of proportionality, or my slope, is 3/7, that means I can move up 3 and over 7 to make the next point. So if I'm here and I go up 1, 2, 3, over 1, 2, 3, 4, 5, 6, 7, my point should be right there. And I can do it again if it would fit. Sorry, this keeps coming through. From here, I can say up 1, 2, 3, 1, 2, 3, 4, 5. There's not enough space, so I can just connect my points from here. So then your equation, your y column, is equal to your constant of proportionality times the x column. Your proportional equations are always going to be the same. And again, we're eventually going to see ones that are written a little bit differently, where maybe our graph is shifted up a little bit or shifted down a little bit, and how that affects this. But over here, if there are 1,000 meters in 1 kilometer, how many meters are there in 5?
I'm still confused on the graph, because it looks like we have 7 cups of white paint and 3 cups of red paint.
Oh, but I don't know why they're written that way.
What?
You are right. What'd I do? Yep, I flip-flopped them. So if we come here and plot this point, come over, oh no, we were right. 7 cups of white, look, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So we put that back. How many cups of white paint do we have? 7. 7 cups of white paint. Red paint is 3. There's 3 cups of red paint. You see what I'm saying?
Oh, I don't know where my brain was going.
It's okay, because you said that and I just did the same thing and I was like, oh right, that doesn't make sense. But it does. And again, you could have just plotted this point. Like I could have counted over 7 and up 3 and plotted that. I just decided to go up and over first because that's how the slope makes us move. But it's all the same thing.
So which point were you plotting? Were you doing?
So I was moving based off of the slope. So I went from the origin, and slope tells me that we can go up 3 or over 7. But it's the same thing if I think, well, I'm just going to plot this coordinate point, and I'm going to go over 7 first and up 3. It doesn't matter the direction that you go. Up 3 over 7 is the same as over 7 up 3.
So then how would you plot the first point?
So I would come over to 1, and then up to 3/7, which is hard to assume where 3/7 is, but it would be somewhere about there. This is your x, this is your y. So come over to 1, up to 3/7. And again, that's where your constant of proportionality shows up in that graph. Any other questions on that? So then for B, it says there are 1,000 meters in 1 kilometer. So how many are there in 5? 5,000. Okay. My k value, or my slope, my constant of proportionality, my rate of change, all the same thing, is 1,000 meters per kilometer. So that means multiply it through and we get 5,000. If there's 20 kilometers, how many meters are there? Yeah.
20,000.
Right. We're just taking that value. Constant rate of change means you can multiply everything in the left by the same number. So then 0.3 times 1,000. So then if I wanted to write an equation to represent this, X is always your first column, Y is always your second column. We get the numbers in the right-hand side by taking 1,000 times the numbers in the left-hand side.
I don't have a calculator, but wouldn't 1/10 of 1,000 be 333?
No, because that would be if there's only one here. So then there's only 1 3 here. So then like your number value stay the same, you're just basically losing the 0. So now we're gonna graph it. And again, if we're having trouble estimating where the points are, because we're counting by something weird here, this is just telling me my slope. So this is telling me that from the origin, I can move up 1,000 units and over 1, which doesn't seem that easy to do here because I'm in terms of 4,000s here, 2,000s if we see each other line. So I am going to go about this one by maybe plotting the coordinate points. So if I have 5 kilometers, I have 2, 4, 6, 5 is somewhere in between here, and then I'm estimating about where 5,000 is going to be. And again, it's kind of hard to estimate where they are. But you're using the knowledge that these points have to form a straight line, so use that to guide how you're doing it. If I come over to 20 and then up to 20,000, that's a nice neat point. So then connect them through. Again, you see that same slope. You can find your slope between 2 points, but it also shows up in the graph when X is 1. So some of your first set of homework problems gives you a bunch of equations and gives you a bunch of graphs, and you have to match each graph to the equation. So whatever that number is that shows up in your equation also shows up in your graph when X is 1. Any questions on any of that? So we're going to look at 2 other graphs. One compares the side length to a perimeter. And then the other asks us, we have no information in the table and we kind of have to figure out that constant of proportionality to make it through. So for part C, what is the constant of proportionality in my table? We're comparing the side length of a square to the perimeter. So what is my slope or my rate of change or my constant of proportionality? What would it be in that table? Casey?
Perimeter 1.
Right, because I can find it by taking any row in the table and dividing it out. 8 divided by 2, 13 divided by 3 gives us 4 over 1. So if I wanted to write an equation to represent this, even if I wanted to not use X and Y and just use the letters in the table, we can find the perimeter by taking 4 times the side lengths. So then if we go to graph it, either plot your coordinate points or move based off of your slope. But based off of what we're scaled by here, since I'm counting by 5s, it's going to be hard to count in terms of 4. So I'm just going to plot my points again. I have 2, 8, so 2, 8, maybe somewhere in between 5 and 10, 3 and 12. Again, they should form straight lines. So do your best to plot a couple and connect them through. And again, your constant of proportionality shows up there when X is 1. And then in the last one, we have that a performer expects to sell 5,000 tickets for an upcoming concert. So 5,000 is a big number, so I'm just going to put it here. They want to make $311,000 from selling that many tickets. What is the cost per ticket? So if I have 1 ticket, how much is it going to cost? How would I figure it out? If I want 5,000 tickets to cost $311,000, how would I figure out what the 12 tickets would be? So then, if I want to make that much money, how much do I have to sell 1 ticket for? Daniel?
$62.
$62
or 20 cents.
and 20 cents.
Yeah.
Is that okay? Warning you for when you get older and want to go to concerts, that's pretty cheap. That is definitely pretty cheap. Like if I'm going to a concert and it's $62, I'm like, oh, I'm definitely going. Like they get expensive. I guess depending on who you're gonna go see. Like popular people, like a Taylor Swift concert ticket, you're never finding it for that. They're like a lot.
I thought it meant like a movie ticket.
Oh no. I guess it doesn't really. It just says a performer, so I guess it could be like a play or something. And it seems expensive, but then you'll compare it to some other costs, and you're like, oh man, that's really cheap. I'm getting it. So then, typically in some tables, if I just put an X here, X could represent any number of tickets. So then, how would I write an expression to figure out the cost for that number of tickets? Is that what you're gonna say?
Yeah.
Yep. So 62.2 times X. You don't have to say equals Y because it's in the like Y column of the table. So you find your sales by taking 62.2 times X. So that's our equation. So then pulling our equation down here, just like Abby was saying, the cost is equal to 62.2 times the number of tickets. Draw your graph in. So I have, pay attention to your scaling because we're in thousands of tickets here. So I'm gonna plot this one first because 1,000, if I try to plot one, I'm not even really gonna be able to see it. So I have 5,000 tickets, is $311,000. So I'm in 100,000 on the Y. So I'm gonna come over to 5 and kind of estimate just past the 3, because that's gonna represent 300,000. And then again, you don't have to try to plot everything. Your proportional graphs start at 0, 0. If you have a point, do your best, which that's a little wobbly, but to just draw a straight line. Because then every other point should fall on that line. 1 comma, somewhere way down here. 1 comma 62.2 should be on there. But if we're in thousands, then 1 is really, really, really hard to see on that graph. So you can't be too sure where it is. Good with that? Okay, so your homework is the rest of that. You guys are going to be back here first period where you can work on it. It's a handful of questions. And like I said, that first part is asking you to match the equations to the graphs. So that number that shows up in the equation is the same number that shows up in the graph when X is 1. So you can look at it that way. There's about 5 minutes you can get started on that.
So is this the X value?
So for A, your equation is Y equals 2X. So the coordinate that would be on the graph would be 1 comma 2. So this is your equation. So this is the slope of the
Oh,
line.
yeah.
So your slope of the line. So then you're looking for coordinate point 1 comma 2. This you're looking for 1 comma 4. But pay attention to what you're counting by on those graphs. It's easier if you think in terms of like thirds and fourths and fifths. That's what your equations are written in terms of. Think about that. You guys will be back in here tomorrow morning to start working on this. You guys at home, if you have questions on this, log in tomorrow morning. But you are free to, at this point, sign out to keep working on that.